And to find the plug and chug, you would plug -4 into the equation. -4 squared plus 8 times -4 plus 6. Please be careful with your arithmetic. -4 squared is 16 minus 32 plus 6, giving you a y value on the plug and chug of -10. So our vertex is -10. That's really about half the work for this problem. We're about half done with the work already. Okay, finding the vertex is half the battle, and you've already been doing that for the whole chapter. What we're going to do next, though, is new. We are going to place the vertex into vertex form. Vertex form you've never seen before, but it's no great shakes. It's on the wall over there between the clock and the flag above Bam Bam's head. A times the quantity x minus h squared plus k. It says y on the wall. For our purposes in this chapter, we're going to set it equal to 0. And what we're going to do is we are going to substitute values in for a, h, and k. H and k are the vertex. H comma k is the vertex, which we just found. And a comes from the problem, the leading coefficient of the problem, the same a that we used to find the vertex. Okay, so values are going in for all three of those purple highlighted areas. A, H, K. A in our problem, since I've moved to a new slide, I'll tell you, A is 1. H was -4. And K was -10. Our vertex was -4, -10. And A was 1. The leading coefficient, if you look at your problem, is 1. And we're going to substitute those values in for those purple areas. Now, the formula, or the vertex form, is x minus h. So what we need to write is x minus -4. Well, how would I write that? X plus 4. And then I write plus k, which is plus -10. How would I write that? Minus 10 equals 0. So we've replaced A, H, and K in the stock formula with the values from the specific problem, 1, -4, -10. And now what we're going to do is we're simply going to solve that for x. We're going to peel away the layers until the x is by itself. The first step would be to move the 10 over. So we're going to solve it. So I'm going to move the 10 to the other side. Next, I would divide by the 1, or the a. Since it's 1, I really don't have to divide by anything there. The next layer we need to get rid of is the square. And to battle a square, you take the square root. So when I take the square root, and remember when you take the square root of both sides of an equation and you have a number, you put plus or minus 10, root 10. Square root both sides. And then last step would be to move the 4. So your answer is -4 plus or minus root 10. Those are the two numbers. There's two numbers there. -4 plus root 10, -4 minus root 10. Those are the two numbers that work in the equation if you plug them in for x into the original problem. I knew it was going to be something a little gross because the problem wasn't factorable at the beginning. So that's how you use the vertex form shortcut to solve a quadratic equation. Let's look at another one together. (2x squared minus 12x minus 11). The three basic areas of the problem are finding the vertex, putting it into vertex form, and solving. So if you want to break it up into manageable parts, those would be the manageable parts. So first, finding the vertex, which you're all familiar with. Opposite of b over 2a, comma, plug and chug. Opposite of b is 12 over 2a, which is 4. And so my x-coordinate of my vertex is 3. So now my job is to plug 3 into the equation and see what I get. And I get negative 29. So my vertex for this one, 3, negative 29. We're going to move the vertex and the a to vertex form. A is 2, h is 3, k is negative 29. A is 2, h is 3, k is negative 29. You can just get that right off the wall, set it equal to 0, substitute the values. And now we have to solve that for x. Step 1 would be adding the 29. Step 2 would be dividing by 2. You want it to be just a square on the left side. You want to move all the superfluous numbers before you take the square root. So that's why I moved the 29, move the 2, clean that side up a bit, so then we can take the square root of both sides, which is what I'm going to do next, giving me x minus 3 is plus or minus root 29 halves. At this point in our mathematical career, at least in trig, we have not done simplifying of roots like that because we don't know what the square root of 29 is or 2. If that would have said 36 over 9 or 36 over 4 or 64 over 9, those perfect squares, we can simplify those. But with 29 and 2, we can't. So we're just going to leave it, and we're going to add the 3 to the other side, and we're going to call that one done.